Imagine teaching a robot to walk, a car to drive itself, or an AI to beat the world's best players in chess, Go, Dota, or StarCraft. But here's the twist. You don't explicitly tell it how to do any of it. You simply reward it for good actions and let it learn through experience. That's reinforcement learning, the branch of AI responsible for some of the most jaw-dropping breakthroughs in modern technology. Today, we'll break down how it works, the math behind it, real-world use cases, and how RL is shaping the future, all in a simple, practical, curiosity-fueled way. What is reinforcement learning? Reinforcement learning, or RL, is a type of machine learning where an agent learns by interacting with an environment. Think of it like training a pet. If it performs a good behavior, reward. If it does something bad, punishment. But unlike a pet, an RL agent doesn't get frustrated. It keeps trying, endlessly, and eventually discovers strategies humans never imagined. The core loop of RL. The agent takes an action. The environment responds with a state. The agent receives a reward. The agent updates its strategy or policy. The loop repeats thousands or millions of times. This is called the Markov Decision Process, MDP framework. Real-world examples to make it click. Let's bring RL into the real world. 1. Self-driving cars. An autonomous car learns when to accelerate, brake, and take turns by simulating millions of driving scenarios. Smooth turns, reward. Collisions, huge negative reward. Getting to destination safely, big reward. 2. AI plays games better than humans. DeepMind's AlphaGo and AlphaZero use RL to discover completely new ways to win, not by copying humans, but by experimenting. 3. Robotics. Robots learn to grasp objects, balance on two legs, navigate spaces, all through trial and error. 4. Finance. RL agents adjust investments dynamically based on market movements, optimizing returns over time. 5. Personalization. Even your YouTube recommendations use RL to maximize your satisfaction over long-term engagement. How does RL actually work? Now, let's break RL into digestible parts, the secret sauce behind the breakthroughs. The policy, the brain of the agent. The policy tells the agent what action to take in any given situation. You can think of it as, if I see this, then I do that. It can be deterministic, always picks the same action. Stochastic, picks actions with probabilities. The reward function, the motivation. Rewards define what the agent should aim for. Designing rewards is hard. If you reward the wrong thing, you get weird behaviors, like an AI learning to crash into walls because it mistakenly gained points for doing so. Value functions, estimating the future. RL isn't just about immediate rewards. An agent must think ahead. A value function estimates how good it is to be in a certain state, considering future rewards. Q-learning, the most popular RL technique. Q-learning teaches the agent to evaluate. How good is it to take a specific action in a specific state? It builds a Q table with state and action values. But real-world problems are too big for tables. So we use Deep Q Learning, DQN, replacing tables with neural networks. This led to AI mastering Atari games straight from raw pixels. Deep reinforcement learning. Deep RL is where things get wild. AI plays Atari games directly from screen images. It doesn't know what a paddle or ball is. It just sees pixels, receives rewards, and experiments its way to mastery. Policy gradient methods. These algorithms directly optimize the policy using calculus. The agent learns not by building tables, but by continuously nudging itself toward better decisions. Actor-critic models. Two brains inside one system. Actor decides actions. Critic evaluates them. Used in robotics, gaming, simulations, and more. Real-world case study. Let's look at one real example: Google's data center optimization. Google used RL to cut their cooling costs by 40%. An RL agent learned how to adjust fans, pumps, and temperature settings thousands of times per day. And it optimized energy use better than human engineers. This is RL quietly saving the planet. Why RL matters for the future. RL is not just another AI technique. It is the closest thing we have to machines that can learn like living beings through curiosity, experimentation, and experience. As RL progresses, we'll see breakthroughs in autonomous factories, personalized medicine, adaptive learning platforms, household robots, next-generation gaming, climate optimization, smarter cities. The world is shifting from machines that follow instructions to machines that discover their own strategies. And reinforcement learning is leading that transformation. If you enjoyed this deep dive, don't forget to subscribe for more weekly AI explorations. Until next time, stay curious.